All right, guys, page 5 of this AP Calculus packet. Let's get started. Let me do a share here. All right. So we have an absolute value function. These two bars mean it's absolute value. Means it's going to be a V-shaped graph. And because it's a negative in front, it's going to be upside down V. So what I'm going to do, I'm going to basically use a table to graph this. So X and f of X. And I'm going to look right here in the middle. And this is going to be what we would call our vertex. This number right here, you see a plus here, it means the opposite. So it's -3. And the 2 here means what you see is -3, 2. That's the vertex of this graph. That's this point right here. So -3, 2, move to the left, 1, 2, 3, and down 2. So I know I have a point right here. The vertex is right here. The graph is going to do this. So I'm going to put that point in the middle. So that's -4, -5, -2, -1, 0. All right, so let's plug in points and see what happens. So if I plug in 0 in here, so 0 plus 3 is 3, but I have a negative here. So a -3 is going to be -3 minus 2 is going to be -5. So I know that I have a point right here. -1, if I plug it in, -1 plus 3 is 2. The absolute value of 2 is 2. And I have a negative out here, so it's -2 minus 2, which is -4. So there's a point right here. -2, if I follow my pattern, that means my next point, -2, is going to be here. And my next 2 points, -4, -5. If I follow the pattern, this is a reflexive graph. What's going to happen is -4 is going to be right here at -2, and -5 is going to be right here at -3. So it's going to be a reflexive graph. So I already know that that's what's going to happen. It's reflexive because here's the vertex, and it reflects in both directions. So here's my picture. So how do we do the domain? Remember, if it's a absolute value, the domain is always all real numbers. The range is based upon the highest or lowest point. So the highest point is at -2. We know it's at -2. So the question is, does this go up or down? Okay, and we know the range is always described with the letter Y. And since it's facing down, is less than or equal to -2, because -2 is the second number in my vertex. I look at this number to get my range. They're going to always match. But because it's facing down, it's less than or equal to. All of my range values are all less than or equal to -2. Okay? So let's find out what 3 is equal to. So let's take 3. This is an X right here. This is the input variable, which is X, and let's plug it in. So if I plug in 3 right here, what's 3 plus 3? 6. Then I have a negative in front. So -6 minus 2 is -8. And you can notice if I come over here, I'm decreasing. That's how -8 is going to show up. Okay. X plus 5. Okay. So let's plug in X plus 5. So if I plug in right here, the X plus 5 right here in place of X minus 2, I add these two together, that's going to make 8. So I'm going to have negative absolute value of X plus 8 minus 2. because the 5 and the 3 make 8. There are no other like terms. That's your output. Okay? So let's talk about f of x equals -3. Now, x is not 3. The output is -3. So that means when it says f of x equals or something, that means we're talking about a horizontal line. It's going through -3. So right here, -3, this is f of x equals -3. It's a horizontal line right here. So where does it intersect at? Where do we see -3 at? Right here and right here. So we have two solutions for x. We have x to be -2 and x to be -4. Because you see -3 2 times in the outputs right here. It says f of x. When is f of x equal to -3? When x is equal to -2 and x is equal to -4. There are two solutions. So we use a table to solve that. All right. Let's graph this piecewise. Okay, so we have 3 graphs here and different domain values. So if I look right here at x, the first graph here, x and x minus 2, well, my domain is x greater or equal to 4, so I got to go 4, 5, 6, 7, and so forth. So if I put 4 in here, I'm just going to go even numbers. 4, 8, 10. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4. 10 divided by 2 is 5. So this is my y, actually. So if I let x be 2, 4, 6, 8, 10. 1, 2, 3, 4, 5. So what would happen? When x is 4, I have 2. When it's 6, it's going to be 3. 8 is 4. 10 is 5. It's a linear function to this point. Okay. I know it's linear because I just see x. From 0 to 4 is quadratic, which means not quadratic. It's going to be a square root function. It's going to do like that. So if I make another table, x, and I put the square root of x, I'm going to try 0. And I'm going to go 1, 2, 3, 4. So 0 is going to be 0. The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is 1.41. The square root of 3 is 1.7. The square root of 4 is 2. So it does this. It does this type of curve. Let me take that back because this is going by 2s. So this is 1, 1. So it really does something like this. That's fine. Okay. Well, no, it doesn't. I'm going crazy. It does this. It never touches that. It goes here. Okay. And x squared, we know that if it's x squared, it does this. That's quadratic. And it says when x is less than 0, which means you got to go -1, -2, -3, -4. So -1 squared is 1, -2 squared is 4, -3 squared is 9, -4 squared is 16. So this is what we know. The graph does this. 2, 4, -2, -4, -6, -8, -10. So we know this. It does something like this. Okay. So we have to use the different tables and domains to solve these problems. So we know it's piecewise, quadratic, square root, linear. Okay, that's what piecewise is. It has different domains and different outputs within the graph. So here we go. So -3, where was that? That's here, so it's 9. 1, where's 1 at? Right here. So at 1, it was 1. 0 is here. In both cases, g of 0 is 0. From both directions is 0. Is g of x continuous function? How do you know? It is continuous. Let me see. No, discontinuous at 2. At x equals 4. Okay. All right. Well, no, wait a minute. No. No, I did it wrong. No, it is continuous. Yes, it is continuous. Okay. And last case, g of 6 is here. So g of 6 is right here. That looks like 2.5. So 2.5. G of 0 is 0. It's right here. 6 minus 0. So it's 2.5 divided by 6. What's that equal to? Let me see. If I simplify that on my calculator, go to my phone. Well, if we work it like this, if we multiply by 2, it's going to be 5/12. That's what it is. So it's really 5/12. B says the ratio of part A is the slope of the line. The ratio of part A is the slope of the line segment joining 2 points on the graph. Sketch the line segment. Oh, wow. Okay. Joining 2 points. Okay. We have a point at wait a minute. Here. Those are the 2 points right there. Okay. I'm gonna stop right there, guys. And if you have a question, reach out to me. But I'm gonna stop right there. That should be it. That should have cleared up that problem. Because there's your graph right there. They want you to sketch the line segment.